All right, our last lesson for the day, lesson 12.5. You should still have your notebooks out. This one is titled Change of Base Theorem and Half-Life. Problems. Change of base theorem and half-life problems. Okay, today we are learning how to work with problems. I told you guys earlier we will have problems where you can't get them to the same base. What do you do? That's what we're going to learn today. All right. Change of base theorem. Number one, I'm going to write solve. Number one, log base 5 of 30 equals x. All right, we've learned before to solve these, we wrap around. 5 to what power? Not 5 to the 30th. 5 to the x equals 30. And we've been doing that for a few days now, and at this point typically we would get them to the same base, which would be 5 to the x equals 5 to some power. But is there any way to get 30 to a base of 5? I know that 5 times 6 is 30. Is that the same as saying 5 to the 6th power is 30? No, it is not. So there is no way to get these to the same base. So what we're going to do, and I don't know if you did this last year, we're going to take the log of both sides. All right, I said take. We're not going to multiply both sides by log. We're going to take, kind of like taking the square root or square rooting both sides. We're going to take the log of both sides. So it looks like this. Log of 5 to the x equals log of 30. This is not log times 30, it's log of 30. This is not log times 5x, it's log of 5x. Take the log of both sides, not multiply both sides by log. There's a difference. All right, a few things we should notice. One, I didn't write a base, purposely done so. I didn't write a base because what's the base? Correct, it's 10. Now, of all the numbers in the world, why would I choose base 10? Because base 10 is programmed in our calculators, and we want to be able to plug these in our calculators eventually. So, of all the bases in the world, we use base 10. Why? Because that's what our calculators are programmed. We could use ln, base e, but we just use log base 10. All right, now log law number 3 allows us to do what with the power, which is the whole reason why we take log of both sides. To do what with the exponent? Get it out. We don't want the exponent up there because we can't solve it when it's an exponent. We don't want the variable as an exponent because we can't solve it when it's up there. Okay, so x times log of 5 equals log of 30. Again, remember the two bases here are base 10s. All right, I want to solve for log. I want to solve for x. And log 5 is a decimal hiding in my calculator as well as log 30. So what I do is I divide both sides by log of 5. Why? Because I'm trying to get x by itself. Again, I divide both sides by log 5. Why? Because I'm trying to get x by itself. If any of you are working ahead of me, do not go too fast, because you cannot reduce the 30 and the 5. Okay, if it was written like this, which is, there is a difference, log of 30 over 5, that you can reduce to log of 6. That is okay, everything is hunky-dory, we're good, we're happy. Do you see the difference between these two? and I've talked about it before, this is log of a fraction, which I can reduce, or this is a fraction with logs, which I cannot reduce. Two different things. Okay, understand that and recognize cannot reduce, over here you can reduce, which is a completely different problem. All right, so back to where we're at here. I cannot reduce, but I can plug this in my calculator. Log base 10 of 30, I can plug in because my calculator is programmed with base 10. Log base 10 of 5, I can plug in for the same reason. The calculator is programmed with the base 10. So I'm going to turn this on. Hopefully you can see it. There it is. Okay, I'm going to type in, my log key is right up here next under my second key. Log of 30, close parentheses, just like we used to with our sine and cosine, divide by log of 5. And there is our answer, 2.113. We'll go out to 3 decimal places, to the thousandth place. So x is 2.113. So this is saying 5 to the 2.113 power is 30. Now because I rounded it, it's not going to be exactly the same if I were to plug it in. 5 raised to the 2.113 power should come out to be pretty close to 30, and it does, 29.986. Make sense? Again, you don't have to show that work. This is just showing you that it indeed truly does work. All right, let's try another one, and then we're going to try to figure out the change of base and how does it work. All right, let's try log base 12 of 7 equals x. Okay, we do the wraparound. 12 to, not the 7th power, 12 to what power? To the x equals what? 7. And you can see right off, there's no way to get these to the same base. 12 to the x equals 7, not possible. So remember, what do we take of both sides? We don't multiply. What do we take of both sides? We take the log of both sides. So I do log of 12 to the x equals log of 7. And make sure you say it properly, not log times 7, log of 7. Log of 12 to the x. And what's the whole reason we do this? I said on number 1 to do what with this exponent? Bring it down, bring it up to the coefficient, because we want to solve for x, and we can't solve for x when it's sitting up in an exponent. So we bring it down. X times log 12 equals log 7. Now remember that log 12 is a number in our calculator waiting to come out, as well as log 7. They're both decimals in our calculators. Now, I didn't say it like I did earlier, but remember, of all the bases, what are the bases here that I'm using? 10, we don't have to write them, but we should know it. And why do we choose base 10? Because it's in our calculator. All right, what do we divide both sides by? To solve for x, we divide both sides by log of 12. Log of 12. That crosses out, not the 12, the log of 12. All of it crosses out. Now, even if these numbers were reducible, I cannot reduce. I plug it in as I see it. Log of 7, close parentheses, divide log of 12. 0.783. 0.783. All right, now we're going to try to come up with the change of base. Let's see if we can come up with a pattern, because you're going to have some on homework tonight where it says evaluate the logarithm by using the change of base theorem. All right, so we want to know how to use the change of base theorem. So let's take a look. This is what was given to me. I did all this beautiful work, and this is what I plugged in the calculator. Log base 5 of 30, and I typed in log 30 divided by log 5. Let's take a look at this one. This is what was given to me. We did all this beautiful work, and this is what we plugged in the calculator. It was log base 12 of 7, and we typed in log 7 over log 12. Does anybody see a quick shortcut we can do here? Change of base theorem states if I have log base, we'll use log base b of a, and I want to plug it in my calculator, I can do all this beautiful work, which is really beautiful and not a problem doing it. But if we want to save time and we're trying to use the change of base theorem because it's asking us specifically to use it, we should recognize that it equals log of A divided by log of B. All right. Okay. Let's see if that works. Log of A over log of the base. Log of 30 over log of the base 5. Is that what we typed in? It sure is. Log of 7 over log of the base 12. Log of 7 over log of the base 12. That's exactly what we plugged in. All right, so let's take a look at one. It's going to say something like this. Evaluate using the change of base theorem. We'll call this number 3. And we're going to try to go a lot quicker here. All right, let's try log base 3 of 17. Okay, without doing all this beautiful work, what's the quick and easy way to plug it in our calculator? Log of 3 or 17? Log of 17 divided by log of the base, which is log of 3. And you simply plug it in your calculator. And you're probably thinking, well, why did we do all this stuff over here? You could have just given us the formula. Yeah, I know. It's because I love you guys, and I want you guys to understand this stuff, because we're going to use this on the next set of notes and the next set of problems anyway, and it is a concept you do need to understand. All right? Okay, so we plug this in our calculator. So we get our handy-dandy calculators out, and we type in log of 17, close parentheses, divide log of 3 equals 2.57. 3 decimal places would be 578 or 579. 2.579. All right, last one like this, and we're going to move on. Log base 6 of 0.1. Again, I still want you to use the change of base theorem. Fraction, what comes top? The top, 0.1 or 6. Log of 0.1 over log of the base, which is 6. And you plug it in your beautiful calculator. Clear log 0.01, close parentheses. Don't forget to close. Divide log of 6. 3 decimal places. Negative 2.50. Oh, yeah, so that did not work, and I'm sorry guys if you are not getting what I was getting, because I did plug it in wrong, and I apologize. Can you see where I messed up? I said 0.1, but I typed in 0.01. So I'm going to fix that because the answer was not coming out properly. Log 0.01, close, divide, log of 6. Oh my good grief, can I not plug it in correctly? Log of 0.1 divide by log of 6. And finally, I typed it in correctly. All right, log of 0.1 or 0.1, if you typed it in that way, it still works. Log of 0.1 divide by log of 6. We still get negative 1.285. All right, that's what you're going to be doing for the first 4 problems, is this whole change of base concept. And if you understand it fully and completely, you no longer have to do all this work for those first 4. You just log A over log B, and all is good. All right, let's move on to the other types of problems you're going to see. I'm going to write here, solve. And it doesn't say solve using or evaluate using change of base, it just says solve. Number 1, 8 to the x equals 214. All right, can I get these two to the same base? I cannot. 8 squared is 64, and 8 to the 3rd is 512. So there's no way to get those two to the same base. Not even 2. 2, I can get that at 2 to the 3rd, but 2 to no power is going to give me 214. So what we're going to do is what we did on the beginning problems. And what did we do to both sides, or what did we take of both sides? We take the log of both sides, which is what we're going to do. Log of 8 to the x equals log of 214. And since we've done enough of these, they should come fairly easy. The whole reason we do this is to do what with the exponent? Bring it down as a coefficient, because we want it's a variable. We want to be able to solve it, so we bring it down. X times log of 8 equals log of 214. And I want to solve, so remember these are all decimals hiding in our calculators. We divide both sides by log of 8. And as tempting as it is, am I mathematically allowed to reduce the 214 and the 8? We are not. We are not allowed to. Remember, we said that earlier. A fraction with 2 different logs, you're never ever allowed to reduce. So we don't reduce them, but we simply plug them in our calculator. And again, why do we use base 10? So that we can use our calculators. All right, let's see if I can get this in screen. Log of 214, close parentheses, divide by log 8 equals 2.580. And yes, you put that 0. It's on screen. 2.580. And yes, you put the 0 to show that you round to the 3 decimal places, and it was indeed 0. It wasn't just left off at the 8. All right, another similar one to that one, number 2. E to the 2x equals 12. All right, now think really hard about this one. What did we do on this one? We took log of both sides. And I've said it before, of all the logs in the world, why do I use log base 10? So that I can plug it into my calculator. And the very beginning, I said you have another log in your calculator, not just log base 10, but log base E. And I said at the beginning you could use that one, but I typically don't unless it's an E. If there's an E in my problem, I'm going to use log base E. Why? Because it's easier. I'm going to repeat that. If I'm solving an exponential equation and there's an E in my problem, I'm going to use log base E, which is ln. So I'm going to take log base E of both sides. Log base E is ln. Why? Because it's easier to plug in your calculator at the end. All right, here I did log base 10, log base 10. Here I'm doing log base E, log base E. Even though I don't see the E is still there. All right, I do that so I can bring this guy down to the front. 2x times ln of E equals ln of 12. Does anybody know what ln of E is? Anyone? I'm going to put a little thinking bubble over here. ln of E equals x. Remember there's a base E here. E to what power equals E? E to what power equals E? Does everyone see that it is 1? So what is ln of E? It is simply a big fat 1 in disguise. Take you a second to digest that, and then I'll show you over here. Log of 10 was 1 because log base 10 of 10 is 1. 10 to the first power is 10. Log base 5 of 5 is 1. Log base 7 of 7 is 1. Log base 8 of 8 is 1. Log base E of E, or ln of E, is 1. ln of E is 1. So I'm left with 2x equals ln of 12. Divide both sides by 2, and I still cannot reduce, and I plug it in my calculator. Ln of 12 divide by 2. Ln of 12 divide by 2. Ln key, not the log key, 12, close parentheses, divide by 2. 1.242. X equals 1.242. All right, I'm going to show you one more before we move on to the half-life problems. Number 3. Seven to the negative x equals 500. Again, we cannot get them to the same base. And if you cannot get them to the same base, you do what to both sides, or you take what of both sides? Correct. You take log. Log of 7 to the negative x equals log of 500. And the whole reason we do this is to bring this exponent down to the front, because we want to solve for x, and we can't as long as it's up as an exponent. Negative x times log of 7 equals log of 500. I'm hoping we've done enough of these for you to have the hang of it by now. We want to solve for x, so I divide both sides by log 7. Oh, forgot my g. If you wanted, you could divide by negative log 7 and get rid of the negative sign right off. That is totally up to you. I don't want to confuse anybody, so I won't do it just yet. And then I plug it in my handy dandy calculator. Log of 500, close parentheses, divide by log of 7, 3.193 or 3.194. 3.194. Divide both sides by the negative. X equals negative 3.194. Got the hang of it? All right, we are moving on to half-life problems. This is homework problem number 14. All right, I'm just going to do homework problem number 14. So I'm going to put it up here so we can read it. Find the half-life of strontium-90 if K equals 0.0246, where A equals, we call this A naught, A equals A naught e to the negative KT, and T is expressed in years. All right, let's just write that down. Find the half-life K equals 0.0246, where A equals A naught e to the negative KT, and T is expressed in years. Okay, this whole half-life business, you really need to make sure you're paying attention to, because it can get a little tricky if you're not paying attention. And we're going to use this concept when we're dealing with interest problems, when we're investing money in banks and we want to double or triple our investment. We're going to use the same concept that we're doing here with the half-life. Okay, what is what? The final answer, A, is your amount. AMT stands for amount, is your amount after the given time. All right. Again, A is your amount after a given time. A naught is your initial amount. Again, I'm using AMT for amount. A naught is your initial amount. E is 2.718. It's a number in your calculator. K is a constant. In this case, they gave it to us. It's right there. And what is T? I almost gave it to you. T is time. In this case, it is in years. All right. What did they give us? What are we looking for? What did they not give us? Okay, find the half-life. That means we're looking for T. We're trying to find the amount of time it takes for us to end up with half of the amount we started with. We are looking for the amount of time it takes for us to end up with half the amount of what we started with. I'm going to say that one more time. We're looking for the amount of time it takes for us to end up with half the amount we started with. Okay. Did they give us K? They sure did. Did they give us T? No, that's what we're looking for. Did they give us A, or did they give us A naught? They did not. That is where it can get tricky. Whenever they do not give you your initial amount, make your initial amount equal to 1. You can technically make it equal to any number you want. I'm picking 1 every single time. So if A naught is 1 and E is E, negative K is 0.0246 and T is T, we're looking for it. Okay. A naught is 1. Why? Because I picked it, and I'll show you why in just a second. A naught is 1. E is E. Negative K, K is 0.0246. T. and we want to know how long it takes for us to end up with half of what we started with. Well, if we started with 1, what's half of 1? Half. And that's why I pick 1. Now, technically, if you wanted, I'm going to erase this, but I'm going to put it back, so don't erase yours. I could have picked 8, just because I wanted to. And I want to know how long it takes to end up with half of what I start with. What's half of 8? 4. In the end, eventually I'm going to divide by 8, and 4 divided by 8 is going to equal 1/2. I could have picked 12 to start with. And how long does it take to end up with half of what I started with? And what's half of 12? 6. And then when I divide by 12 and divide by 12, I get 1/2 anyway. So how you do it is up to you. From here on out, I will always be choosing what for my initial when they do not give it to me? 1. And then I want to know how long it takes to end up with half of that, and half of 1 is 1. All right, so when we're dealing with compound interest and we're investing money, we want to know how long it takes to double the amount we start with, or triple the amount. We'll put 1 here and 2 here, or 3 or 4, depending on how big we're trying to make it. One more time. When they do not give you your initial, whether it's half-life or an investment problem, you make it 1, and your A, or whatever this letter is on this side, P, whatever it may be, equals, in this case, half, or 2 if you're trying to double, or 3 if you're trying to triple, and so forth. Okay, I'm going to get started on this problem. I just want to make sure everybody's understanding what I've said. All right, is this 1 needed? Yeah, you can think of dividing 1/2 divided by 1 is still 1/2. All right, I'm trying to solve for t, and where is t? T is in the exponent. Just like it was over here, x was in the exponent, and so I took the ln of both sides to get the 2x down. I'm going to do the same thing here. What am I going to take of both sides? Log base e, which is ln. All right, I'm taking ln, I said it earlier. We could use log base e or log base e, and if there's ever an e in your problem and you're taking a log of both sides, then use log base e. Log base e is ln. All right, ln of 1/2 is a decimal in my calculator that I will plug in later. The whole reason we do this is to do what with my exponent? Bring it down, negative 0.246 t times ln of e. And we talked earlier about what ln of e is. What's log base 5 of 5? What's log base 7 of 7? Log base 10 of 10. Log base e of e is a 1. So I have ln of 1/2 equals negative 0.246 t. And I'm trying to solve for t. So what would I divide both sides by? Negative 0.246, negative 0.246, gone. And this is what we plug in our calculator. If you've got it, go ahead and plug it in. I'm just going to go through quickly and explain one more time. Use the given formula, and because they didn't give me the initial amount, I will always make the initial amount 1 unless it's stated otherwise. It asked us how long does it take for us to end up with half of what we started with, and half of 1 is a half. Plugged in K, I'm looking for T. And E is simply a number in my calculator. I'll worry about it later. Drop the 1 or think of dividing by 1, however you think of it. This is what I have. I take ln, or log base e of both sides. Ln of 1/2 equals ln of this exponent, which I'm going to bring to the front. That's here. Bring it to the front. Ln of e. Ln of e is a big fat 1 in disguise, which times by 1 doesn't change anything. I'm left with this. Divide ln I'm going to type 1/2 in as 0.5. It's up to you. Divide by negative and before I do plug it in, sorry for forgetting the 0. Some of you probably caught it and were waiting for me to catch up, and I finally did. All right, I'm going to start over. So it didn't change any of our work. I just forgot to put a 0. I'm putting it back in. I'm going to plug it in now. Ln of 1/2 divided by negative 0.0246. All right. Ln of 0.5 divided by point back up negative 0.0246 divide by negative 0.0246. 28.177 years. The half-life of this element is 28.177 years. It takes 28.177 years for us to end up with half of the amount of what was started with. Definite on the test, by the way.